So today I'm going to be talking about resonance structures, and resonance structures are compounds that have the same molecular formula and the same molecular components. It's pretty much the same molecule, except what's different is the electron configuration is a little bit different. And the electrons are also what make up the double bonds and the triple bonds. Here we're going to be moving the double bonds in order to change where the charges are. So we're going to be moving this double bond over here, and what that gives us is it gives us a similar molecule with the same molecular makeup, except the positive charge is going to be transferred over to this side. Did you see what happened? This moved over here, and so it moves over there. And we have this double-headed arrow to show that the resonance can move back and forth from one to the other. Now we're not done yet, because we can show more resonance structures here. Another one that can happen is this double bond moves over here. And what happens there is this one's here, and this one's here, and the positive charge is at the end. It's a terminal positive charge. Now let's go over to this one here. So this one, for one like this, it's actually really helpful to draw out your hydrogens. So we're gonna redraw this on this side, except we're gonna draw out all the hydrogens. So we're gonna draw out all the hydrogens and also all the electrons. The original structure that I'm copying from has a double bond here. So that's a little, make sure to use more space when you're drawing out yours. Okay, so we have all these hydrogens here, and all the electrons, and we can observe where we can do our switches so that we can change the charges and so forth. And this one needs, yeah. So what one would think is, okay, I can move this double bond here, and then the double bond's over there. But what we want to do is we don't want to really do that. We want to actually try to make it so that this over here, we move the electrons here, and the double bond has to go up to the oxygen. So when we represent that here, we draw out our electrons. And the reason we don't want to do that is because we have a lot of, the way this is bonded, if we, the hydrogens and all that, it's not gonna work out that well. So we move this over here, because of all the hydrogens, then we can't just switch around all the bonds just like that. So here we're gonna move this over here, and then this one's gonna be a double bond, and this double bond breaks, and we move the electrons there. So that would be your resonance structure there, and this one has a positive charge, a negative charge, and this one has a positive charge. Now we have here our aromatic ring, and a lot of people get challenged by these kind of problems because they wonder, well, what am I supposed to do here? It's a little bit tricky and confusing. Do I just go around in a ring this whole time? Well, let's break this down again. Let's draw out all our hydrogens. This is a carbon, 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 carbon. And since they all have double bonds, they all only have, well, this one has that other bond. This one, all these other ones have just one hydrogen. This one has another carbon, bond to another carbon, bond to another carbon, bond to another carbon. Single bond, and at the end, so 3 H's. This one has 1 H, and since it has the negative charge there, we just put that. Electrons. This one has 1 hydrogen. This one has 1 hydrogen, and that one doesn't have any because it has the 4 bonds. So this negative charge tells us that it only has 1 hydrogen and it has those electrons. So what can we do? Well, we can transfer the charge over to another part of the molecule. And what we can do that is by putting these electrons over here, and then transferring this double bond over to this carbon. So let's do that here. We move this charge with those electrons over here, and then this carbon, these go to this carbon. You can actually move the bonds to either the carbon or to another bond. You can't move them farther than that because electrons only move short distances, so they move to what's immediately right next to them, and that either means another bond or to the carbon itself. And that gives us a double bond here, and this one right here. And again, this can go backwards, like this, and there we go. Could we go ahead and move this around here and then move this all around back? Yes, we could, but then it will end up with all of this going around, this double bond coming back here, and then this one will have to then go backwards. So it would kind of be a little bit, it wouldn't really work that well.